Hello students, this is SDsir again from the Temple of Excellence, Vidhyaashram Pre-University College, Mysore. My last discussion, we started a new chapter called Electric Potential and Capacitance. Continuing my session today, we will do two important book works. Both of them are clear 5-mark questions appearing in the exam. So before we start creeping on to that book work, we will just recall the definition of electric potential, where we told it is the work done. Again, I highlight on that term, work done to move a charge from infinity to a point inside the electric field. Two considerations we had: charge is moved with zero acceleration against the direction of the field, and the work done to move the charge from one point to another within the field was called electric potential difference. With reference to these definitions, I will start my first book work, first derivation, where I will calculate potential due to isolated point charge. So now I am calculating electric potential due to isolated point charge. ನಮ್ಮ previous discussions ಅಲ್ಲಿ ನೋಡಿದ್ವಿ, point something which is very very small. ಹಾಗಿದ್ರೆ what is the meaning of the term isolated? Which means separate, single. So it is a single point charge, isolated point charge. So ನಾನು ಹಾಗಿದ್ದಾಗ ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಿದ್ದೀನಿ? I am calculating electric potential due to isolated point charge, a single small charge. So to begin with, we will go to the same considerations as we did in our yesterday's class. So what was the first consideration? Point charge. A point charge ನೇನ್ ಕರೆದ್ವಿ? Source charge ಅಂತ ಕರೆದ್ವಿ. So I will consider a point charge plus Q. So plus Q is my point charge which is placed at the point O, and the medium in which it is placed is free space. So it's free space, air or vacuum. Here I consider a point O, and what is placed at this point O? A point charge plus Q. So what will this point charge do? It will immediately create an electric field. It is the source of the electric field. So which is my point charge? Plus Q. Where is it placed? Point O. At that point O, which is the medium in which it is placed? Free space, what I call as air or vacuum. Now what I do is, I will consider one more point P, some other point P in the same air medium, another point P in the same air medium, which is at a distance r from the point O. P ಏನಾಗಿರುತ್ತೆ? One more point in the same air medium at a distance r from the point O, and the entire gist of this derivation, the entire glory of this bookwork is to calculate the electric potential at this point P due to the charge plus Q. So what am I trying to do in this entire derivation? Very simple. I will calculate the potential at the point P due to the charge plus Q. ನನಗೆ ಹೇಳಿದೆ, where am I calculating the electric potential? At the point P. ಹಾಗಂದ್ರೆ ಏನು? What do I mean when I say I have to calculate potential at the point P? Very simple. There is a charge which is placed at infinity. Yesterday I told, somewhere just outside the electric field. It has to be moved to this point P. Observe here, charge which is placed at infinity, which has to be moved to this point P. Again, will it fly? Has the charge got wings? No. Then what do I do? Some amount of work. That work itself is called electric potential at this point P. So when I say potential at the point P, it simply means work done to move the charge from infinity to the point P. That's all. Now, plus Q was my source charge. To test the influence of the field, what do I require? Test charge. Very good. So, I will consider a test charge which is placed here. And my students, you know, test charge is always UPC. And what is the direction of the field? It is always away from this UPC, because like charges, repulsion away from this UPC. So I repeat, I consider a test charge which is UPC in the electric field, and this UPC is at a distance x from the point charge. So this distance x is the distance between the UPC and the point charge, and the field is acting away from the UPC. Now, I make a small consideration. Within the electric field, ಈ electric field ಒಳಗಡೆ, in the same medium, I consider 2 points AB separated by a small distance dx. I repeat, I consider 2 points AB separated by a small distance dx. And these are all the fundamental assertions done. Which was my point charge? Plus Q. Where was it placed? Point O. Which medium? Free space. Where am I calculating electric potential? At the point P. What is this distance from O? R. Now, test charge is the UPC and the field acts away from the UPC. What was my consideration? 2 points A and B separated by a small distance dx. Now students, in my initial step of calculation, I will calculate the force acting on this UPC due to the point charge plus Q. What am I calculating? Force acting on the UPC due to the point charge plus Q. And how will I calculate that electrostatic force? Very clearly I know by Coulomb's law. What did Coulomb's law say? F equals 1 divided by 4 pi epsilon naught Q1 Q2 by R square. General form of Coulomb's law. When the two charges were placed in air medium. Substituting here, F equals 1 by 4 pi epsilon naught, magnitude of the first charge, my source charge, plus Q, into magnitude of the UPC, the second charge, 1, divided by the distance between them, which is x. Don't be confused. R is the distance between the point O and the point P. Here I am calculating the force between point charge and UPC. Therefore, the distance is x. So the electrostatic force here is 1 by 4 pi epsilon naught. The first charge plus Q into the UPC divided by the distance between them, which is x. So R square, x square, or F equals 1 by 4 pi epsilon naught Q divided by x square. So very clearly you see, the force is predominated by the point charge. Consequentially here, the strength of the field does not depend upon the magnitude of the test charge. It only depends upon the magnitude of the source charge and the distance of separation. So this equation is making it very clear. So the force acting on the UPC is 1 by 4 pi epsilon naught Q divided by x square. And as I told, the direction is along OA, away from the UPC. Now recalling back, where am I calculating potential? Sir, ಹೇಳಿದ್ರಲ್ಲ ಇಷ್ಟೊಂದು ಸರಿ. At this point P. What is potential at P? ಅದನ್ನು ಹೇಳಿದ್ರಲ್ಲ sir. Work done to move the charge from infinity to the point P. Very tedious process. I have to calculate how much of work I need to travel from Mysore to Bangalore. Tumba tedious ಆಯ್ತು sir. ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀನಿ? ಫಸ್ಟ್ I will calculate work done to move from Mysore to Srirangpatna, work done to move from Srirangpatna to Mandya, henceforth. Andre, I am calculating the work done to travel smaller intervals. So now I assume an external force is acting on this charge Q, which is placed at infinity. I have pushed the charge within the field and it is at the point A. I repeat, there is some external force which is acting on the charge Q. Now where charge Q is placed, infinity, nenpitkole. I have pushed the charge to some point A within the field. Now the first part what I am calculating is to move the charge from the point A to the point B. From A, now charge is at A, I have to calculate the work done to move the charge from this point A to the point B. The other word saying, I have to calculate the work done to move or displace the charge through this distance dx. How do I do that? First PUC, I have studied the mechanical definition of work. So work done is force into displacement. Very clearly ನೀವು ಓದಿದ್ದೀರಾ. Work done is defined as F dot S, force into displacement. Continuing further, so that work done I have indicated as dW and the displacement is dx. Why dW? Differential W. When you write that small d, this always indicates small parameters, small variations, small changes. They are always represented by this differential d. My dear friends, I told I am moving the charge from A to B. Displacement is very small, dx. Therefore, the work done is also small dW. But my question is, this displacement is the separation between the points A and B. Am I not moving the charge from infinity? Yes. Do I know that actual distance infinity? No. Somewhere outside the field. But I knew after doing some work, small amount of work, charge was placed at A. Then I moved to a small interval B through a distance dx. That is why I am treating the displacement as dx. So dW, small amount of work required to move the charge from A to B through a small distance dx. Now expanding this, dW equals F dx cos theta. ಅದು ಹಾಕು F dx cos theta ಅಂತ ಬರೆದುಬಿಟ್ಟಿದ್ದೀನಿ. Understand, this is a dot product and we know any dot product A dot B is AB cos theta, elements of vector. Vector A dot vector B is always A, B cos theta. So A ಜಾಗದಲ್ಲಿ F ಇದೆ, B ಜಾಗದಲ್ಲಿ dx ಇದೆ. Therefore on expansion F dx cos theta. Now what is the value of this theta? That is the chef for my derivation. ಏನೋ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಬರೆದ್ರಿ, F dx cos theta ಅಂತ ಬರೆದ್ರಿ. ಅದ್ರ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ಏನು? ವೆರಿ ಸಿಂಪಲ್. The electric field was acting away from the field, whereas the external force was acting into the field. So the displacement was happening into the field. They are anti-parallel to each other. Therefore, theta is marked to be 180 degrees. If they were acting in the same direction and parallel, theta was 0. They are parallel but acting opposite, anti-parallel. The electric field direction and the direction of displacement of the charge. What is theta? Angle between F and dx. Why is it 180? The external force and the field are anti-parallel. Displacement is happening opposite to the electric field. So theta is 180 degree. And you have learned cos 180 is nothing but minus F. Therefore, dw I get it as minus F into dx. I have already calculated the value of F. What was the value of F? 1 by 4 pi epsilon naught Q divided by x square. So my equation 1 was giving it. So I have substituted for F. So what is F? 1 divided by 4 pi epsilon naught Q by x square. ಇಲ್ಲೊಂದು ಮೈನಸ್ ಸೈನ್ ಇದೆ, ಅದನ್ನು ಹಾಗೆ ಬರ್ದೆ. ಈ dx ಹಾಗೆ ಇಟ್ಟಿದ್ದೀನಿ. This I call equation 2. So what is equation 2 giving me? Small amount of work done to move the charge from the point A to the point B. That means from A to B, I have to do a small amount of work, dw. Further, B to some other point I have to move. Again, do a small amount of work which was equal to that dw. Again, from B to some other point. But how will I calculate the total work done to move the charge to this point P? A new method of mathematics called integration. dw, small amount of work to move the charge from A to B. B ಇಂದ ಇನ್ನೊಂಚೂರು ಮುಂದಕ್ಕೆ ಹೋಗಬೇಕಾದ್ರೆ again a small amount of work dw. Again from B to somewhere dw. How will I calculate the total work done to move the charge to the point P? That is where I use a new technique called integration. First year allo odidira. National integration, summing up, addition anta artha. Now, from where did I start moving the charge? From infinity. Adana lower limit or starting limit of integration ant karitivi. Until where did I move? P. What was its distance from the point charge? R. So until where have I moved? R. That is called upper limit. So the lower limit of integration is infinity from where I start, and the upper limit of integration is R. Now follow carefully. How will I integrate? So this is the integration symbol, students. elongated S. S andre sum alva. Elongated S, elongated summation, ade integration. Now, integral dw, I am applying integral signs on both sides. Integral dw equals integral lower limit na yavaglu ಕೆಳಗಡೆ ಬರಿತೀವಿ. Lower limit is always written below the integration symbol. So which is the lower limit? Infinity. Upper limit ಮೇಲ್ ಬರಿತೀವಿ above the integration symbol r. So integral x to r, the meaning is you are moving the charge starting from a distance infinity to a distance r. Between these two limits, the charge is getting displaced. Now this minus 1 by 4 pi epsilon naught q divided by x square into dx. So I am just applying integration symbols on both sides and I have written the limits. Now what will my integral dw on the left hand side give? dw plus dw plus dw, small work plus small work plus small work will give me total work done. So W equals, now follow, how do you integrate the right hand side? First, whenever you have a negative sign, take it outside the integration symbol. So I have a negative sign, I have taken the symbol out. Next, all constants have to be taken outside the integration symbol. 1 by 4 pi epsilon naught is a constant which I take outside the symbol. In the numerator you have q. Is q a constant or variable? Constant. Yake? Single point charge. I don't have multiple charges. Isolated. Single point charge. So q I have taken out. The only thing is x square. So is x square a constant? No. Why? I have moved from the point A to the point P where the distance is getting varied. Dx, there is a change in the distance. So this 1 by x square, I keep it within the integration symbol. ಮತ್ ಪುನಃ ಹೇಳ್ತೀನಿ, ನೆಗೆಟಿವ್ ಸೈನ್ ಇದ್ರೆ ಅದನ್ನ ಇಂಟಿಗ್ರೇಷನ್ ಸಿಂಬಲ್ ಇಂದ ಹೊರಗಡೆ ತಂದಿದ್ದೀನಿ. ಯಾವುದೇ ಕಾನ್ಸ್ಟೆಂಟ್ಗಳಿದ್ರು ಅವನ್ನ ಇಂಟಿಗ್ರೇಷನ್ ಸಿಂಬಲ್ ಇಂದ ಹೊರಗಡೆ ಇಡಿ. ಇಲ್ಲಿ 1 by 4 pi epsilon naught ಕಾನ್ಸ್ಟೆಂಟಾ? ಹೌದು, ಹೊರಗಡೆ ಹಾಕಿದ್ದೀನಿ. ಕ್ಯೂ ಕಾನ್ಸ್ಟೆಂಟಾ? ನಮ್ಮ ಹತ್ರ ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಇದೆಯಾ? ನೋ, single isolated point charge. So q I have kept out. ಉಳ್ಕೊಂಡಿರೋದೇನು? ಈ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಮೇಲೆ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡೋಣ. The charge is moved continuously from A to the point P where potential is calculated. So every time I do some work, that means there is a change in the distance. So that distance is not a constant. So 1 by x square is still retained within this integration symbol. Limits still I carry x equals infinity to x equals r dx. Now, we will now learn how to integrate 1 by x square dx. It is a standard formula which you learn in your math. Integration x to the power n dx is x to the power n plus 1 divided by n plus 1 with integration constant. Your teachers will teach you in math. Just now know integral x to the power n dx is always equal to integral x power n plus 1 divided by n plus 1. Andre, can I rearrange this term in the standard form? Yes, this is x minus 2 dx 1 by x square na x minus 2 ant bardidini. Why? I required that in my standard form. And this is x, power is n, minus 2 plus 1 divided by minus 2 plus 1. N is the power, minus 2, or x minus 1 divided by minus 1, which is minus 1 by x. So what is the integral value of 1 by x square dx? It is minus 1 by x. From where did I get that? Standard formula, x to the power n dx equals x to the power n plus 1 divided by n plus 1. So what is n power? Rearrange x power minus 2 dx. Simplify. So what is the value of integral 1 by x square dx? It is minus 1 by x. Still my limits is not solved. Lower limit, ಕೆಳಗಿನ limit infinity, upper limit r is still retained. Now, do I apply limits for constants or variables? Variables. Why? That means the value of x is changing in between infinity and r. Infinity in the shuru ಮಾಡಿ r ತನಕ charge move ಮಾಡಿದ್ದೀನಿ. So my distance has to vary from infinity to r. And the technique of applying limits is always upper limit minus lower limit. Upper limit minus lower limit. So this is, I write the term outside the bracket as it is, minus q 4 pi epsilon naught. Now in this case of x, first upper limit minus ide, minus 1 by r, minus lower limit, matpura minus ide, lower limit is 1 by infinity. This minus because of the expression. So minus 1 by r minus, yakandre upper limit minus lower limit minus 1 by infinity. This is not defined. Minus into minus is plus. And I keep this work in a standard form, 1 by 4 pi epsilon naught q divided by r. Matpuna ಹೇಳ್ತೀನಿ, integral 1 by x square dx. ಅದ್ರದ್ದು integral value ಏನಾಗಿತ್ತು? minus 1 by x. Still I have not solved what is called the limits. Lower limit is infinity, upper limit is r. So ಯಾವ ರೀತಿ ಲಿಮಿಟ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ತೀವಿ? ವೇರಿಯೇಬಲ್ಸ್ಗೆ. ಯಾಕಂದ್ರೆ the value of x is in between infinity to r, ranges from infinity to r. ಯಾವಾಗಲೂ ಲಿಮಿಟ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಬೇಕಾದ್ರೆ ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಮೈನಸ್ ಲೋವರ್ ಲಿಮಿಟ್ ಅಂತ ಅಪ್ಲೈ ಮಾಡಿ. ಸೊ ಎಕ್ಸ್ ಗೆ ನಾವು ಲಿಮಿಟ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಫಸ್ಟ್ ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಏನು? ಆರ್. ಸೊ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಎಕ್ಸ್ ಆರ್, ಸೊ ಮೈನಸ್ 1 ಡಿವೈಡೆಡ್ ಬೈ ಆರ್, minus lower limit minus, lower limit is infinity, minus 1 by infinity. This 1 by infinity is not defined. So this minus into minus plus, so W is 1 by 4 pi epsilon naught q divided by r. What is this W giving me? It is the total work done to move the charge from infinity to the point P. ಏನು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀವಿ ಇಲ್ಲಿ? Total work done to move the charge from infinity to the point P. And what did I call this work done as? Potential. This is what I have calculated as electric potential. So what is the potential at point P? 1 by 4 pi epsilon naught Q divided by R. So my students, if you observe here, when I derived electric intensity due to a point charge, it was Q by R square, charge by distance square. But here, in simple, it is charge by distance. Know this difference. ನೀವು ಕೆಲವೊಂದು ಸರಿ ಅದನ್ನು ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀರಾ. Intensity is charge by distance square, whereas potential is charge by distance. And this is the expression for electric potential. And very clearly, this expression is valid for any sign of the charge. A positive charge andre plus Q by R, negative charge andre minus Q by R. Why? In simple, potential is a scalar. So this expression is valid for any sign of the charge. Hope you have understood this derivation. Now continuing, now I calculate electric potential due to a system of charges. Previously, it was a single isolated point charge. What was the expression for potential due to an isolated point charge? 1 by 4 pi epsilon naught into Q divided by R. But what have I considered here? It is a system of charges. I have multiple charges. So I consider a system of charges Q1, Q2, Q3, etc. Qn at some distances from my point P. Q1, distance R1 from P. Q2, distance R2 from P. Qn, distance Rn from P. What am I doing in this bookwork? I am calculating now potential at this point P, not due to single charge, but due to the system of charges, resulting potential acting on P when I consider the system to be a system of multiple charges. How do I do? Simple. Calculate potential at P due to individual charges. Then use superposition principle. That is, first, potential at P due to the charge Q1. This is 1 by 4 pi epsilon naught Q1 by R1. Potential at P due to the charge Q2, 1 by 4 pi epsilon naught Q2 by R2, charge by distance. Potential at P due to the charge Qn, 1 by 4 pi epsilon naught Qn by Rn. I want the potential at P due to a system of the charge. So what do I use? Superposition principle. I will find the algebraic sum of the potential. That is, resulting potential is V1 plus V2 plus V3 etc. Vn. Why? Potential is a scalar. You need not resolve components. You need not find angles. Simply superposition principle. See, 1 by 4 pi epsilon naught was common. Take it out. V1, Q1 by R1 plus Q2 by R2 plus Q3 by R3 etc. Qn by Rn. On summation, the resultant potential is 1 by 4 pi epsilon naught. Now, what is the value starting from? 1 to n. So, I is equal to 1 to n. Numerator is charge qi. Again, denominator is distance ri. And this is the expression for potential due to point charge. Dear students, I hope you have understood both the book works. Before I come back in the next session, I expect you have thoroughly studied, practiced both these derivations. Have a good time. Thank you.